Assalamu alaikum and welcome back. Today we are going to have lecture number 12, and which we are going to discuss convolution sums using the graphical method. In the previous lecture we have talked about the LTI systems, and we found that by just knowing the impulse response, which is defined as the output of the system when input is impulse. So if we just know the impulse response, we can find the output of the system. So in this case the system was discrete time system, so using the convolution sum we can find the output of the system. So remember that the condition for the convolution finding convolution sum is that the system must be linear, and it also must be time invariant. So today we are going to discuss the second method of finding the convolution, and this is the graphical method. In comparison with the previous method, which was finding the convolution sum using formula or equation, this one is pretty simpler one, and it requires a lot of less effort. So this is how we are going to find the convolution sum. To obtain the convolution sum, we need to do these following steps, right? So the first step is to obtain h of k and x of minus k, meaning to say that we will replace the independent variable, which is n, by k. The second step is to reflect the, or also called flip or reverse, the one of the signal. For example, if you replace k by minus k in h of k, so you get h of minus k. Then the third step is time shift h of minus k is obtained, and to obtain h of minus k plus 1, we shift the signal by amount of n, so which results into h of n minus k. The fourth step is to obtain the products of h of k and h of n minus k for all values of k, right? And the fifth step is to sum the products, right, h of minus k over all k to get y of n, right? And the sixth step is to repeat these 5 steps for all the values of n, right? So we obtain y of n, right? And it should be clear to you that in step 2 we have mentioned here to flip or reverse h of k to obtain h of minus k. So you can also flip or reverse x of minus k, x of k to obtain x of minus k, so you get same result. So it's up to you whether you flip the impulse response, which is h of k, or you flip the input signal, which is x of k. In both cases you get the same result, right? So based on the steps mentioned in the previous slide for finding the convolution sum, let's have a numerical problem to find the to use those steps and find the convolution sum, or find the output of the system using the convolution sum. Okay, so for example, we have a signal that is x of n, which is defined as shown here. So h of n consists of 2 non-zero samples. At index 0 it has the value 0.5, and at index 1 it has value of 2, and for all other values you can see the value of the input signal x of n is 0. Okay, so As far as the response is concerned, the impulse response is concerned, it has three non-zero samples, as can be seen here in the figure on the top right, that at 0 it has amplitude of 1, at 1 it has amplitude of 1, at 2 it has amplitude of 1, and for all other values beyond 2, right, or beyond -1, these all values are 0. So it consists of only 3 non-zero samples, and all of them have equal amplitude. Now, based on the instructions on the previous slide, let's find the convolution sum, right? So the first step was to plot the signal, both response and the input signal, by replacing the independent variable with k. So that means we can plot it here. So or straight away I just say, okay, I have already plotted using the n as independent variable. Now what I do is I just replace n with k, so it will become k, right? For you have to plot the signal again, right? And okay, and this n is replaced with k, so now you have h of k, okay, and you have x of k. So you replace k with you replace n with k. So this is the first step. In the second step, you reflect any one of these signals, right? So I reflect the signal h of k, right? You can also reflect x of k to obtain x of minus k or h of minus k. So if I reflect it, you can understand how we are going to achieve this operation of reflection. So you understand it's you've already done it while doing the operations on independent variable, right? So the reflected version of h of k can be obtained by placing a mirror here and looking into this side, right? So if I place a mirror here and look into this side, so I will obtain this sample as it is here, and the samples which are at 1 and -2, they will be here, right? So let me plot. For example, this is the original, this is your origin. So let's take red color. Okay, so this is your the sample at 0, and the sample at 1 will be placed here, that is now at -1, and similarly sample at 2 will be at position -2, and for all other values they will be 0, right? Similarly, now again, if I put a mirror here, right, and if I look at in this direction, so you see all these values here, they will be shown, or their image will be produced this side, because all these values, they are 0. So that means I will get something like this, right? And remember that this is your variable, which is k now. So this is what you obtain, that is h of minus k, right? So the next step was to add some negative value, right? So that negative value n, a large negative value n, so that this signal, which is at 0, is shifted to the leftmost. Okay, so let's do it. And okay, I use the same color, and okay, I see it's a bit different. So okay, so this is again the okay, so let me draw here. So okay, and this is the origin. Okay, so if I subtract a big value, if I add a big negative value with this, so originally this is at 0, so now it will become at n. Okay, n is a big negative value, so it's now n. This one is at -1, so this one will be at for example n minus 1. Okay, and then okay, so I have this, and this will be n minus 2, right? So this is 0. Okay, and this is, now we can write it like h of n minus k. Okay, so this is how you obtain h of minus k. So remember, we are using these steps that are mentioned in the previous slide. Okay, so you obtain this. Now the next is that you shift the signal, you multiply the corresponding values of the signal. So if I plot as the input signal again, right? So this is the input signal, for example. Let me plot it here so that it is easy for you to understand what is basically happening. Okay, so this is the input signal. So at 0 it has value of 0.5. okay, this is value of 0.5. At 1 it has value of 2. Okay, so this is 1 and the value of the signal is 2, and this is your k axis. Okay, now we, as mentioned there, in the next step we multiply the two values, right? So you understand the signal is 0, here it is 0, here it is 0, that is 0 up to infinity, right? And similarly 0, 0, right, and 0, and this is up to infinity. Okay, so if I multiply the two signals, what will happen? Because this signal is 0 for all values, right, from -1 onwards. Now this signal is although non-zero, but when we multiply the two signal, you understand, if we multiply two quantity, if one of the quantities is 0, the resulting, it will result into 0. So that means, because this is y of n, so we can say y of n equals to 0, right? And how long it will stay 0? It will stay 0 for all values of n when n is less than 0, right? So this is how you get zeros for right, because one of the signal is 0, then you take the next value of n. Okay, so basically you are moving the signal towards the, in this case, towards the right. Okay, so then you shift this signal right, and again you take the products, because step number 6, if you look at, then it says that we do it for all values of n. Okay, so now we are changing the value of n. Okay, you bring it closer towards this side, so again the product will result into 0 unless you reach at 0. So when n is near to 0, right, I mean when n is equal to, in fact, 0, in that case this signal is non-zero and this signal is non-zero, so the product will be non-zero. Okay, let me plot here again. So I hope this gives you understanding how what we are doing, right? So if I plot the signal again, so it means that so I have shifted the signal this way. Now if you look at this one, this is n, and if you see its index, so it's at position 0, right? So now if you look at this one, so again this sample multiplied with this, it will result to some non-zero values, but this point, right, multiplied by this will again result into 0. Again this point multiplied by this will again result into 0. So we do the product of sums, right? So we take the products of the corresponding values and then we sum them. Okay, so that means in this case now, because n is equal to 0, you understand this is the position of n, and if you see, this is position 0, this is position -1, this is position -2, and this is position -3, and so on, and this is 1, I hope you understand, right, 2 and 3 and so on. So that means when n is now it's 0, when n was here it was at a position of -1. So in that case the product of all were 0. So we can say that y of n equals to 0 when n is less than 0. So less than 0 means at -1, the corresponding products, right? You take the product of the corresponding values that was 0 at -2, -3, -4, -5, and so on, and it stays 0 until n reaches 0. When n is 0, now we see that this one is non-zero and this is also non-zero, so their product will be non-zero, and summing them will result into non-zero value of the y. So when n equals to 0, you see that we can write y of 0 equals to what? Y of 0 equals to so you see 1 multiplied by 0.5 again, because if you move this side, if you move this side, you see all of these are 0, and again all of these are 0. Okay, so 0 into 0 will result into 0. Now at this point, okay, at this point it is 1, and this is this is 0.5 and this is 1, so 1 multiplied by 0.5, right? So it will result this one. Then again this sample is, right, this one is 0 and this is 1, so 1 multiplied by 0. Again this sample is 1 and this is 0, so I write 1 multiplied by 0. So you see 1 into 0, 0, 1 into 0, 0, 1 into 0.5, 0.5. So the value of the yn is equal to 0.5 when n equals to 0. So that's why I have mentioned here y of 0, right? Similarly, we can go for y of 1, right? So again we will shift the signal, so now it is at 0. So if I shift it one more unit, then it will become y of n, and will have value of 1. So okay, I shift 1 unit further this signal, so now you see n corresponds to 1, so that means y of 1, right? N equals to 1, so because it's y of n, so y of 1. What happens at y of 1? You can see that now this signal has value of 1 and this has value of 2, so 1 multiplied by 2, which I mentioned here. Okay, this 1 into 2 plus this is 1 and this is 0.5, so 1 multiplied by 0.5, which is mentioned here again. Now if you look at this one, this is 0 and this is 1, so 1 multiplied by 0, so summing them will result into 2.5. So again, let's move one more step, and now n equals to 2. So for n equals to 2, we have the following, because, right, so for n equals to 2, I will move the signal one unit, right? So here n corresponds to 1, so if I shift it one more, it will correspond to 2. So let's see. Okay, so shifting 1 unit again, now n is at position 2, right? n minus 1 at 1 and n minus 2 at 0. So again we do the same thing, we multiply the corresponding values and sum them, right? So if you look at this one, this is index 2, so here the signal is 0, so 0 multiplied by 1. You understand the response has constant amplitude of 1, right, for all these three samples. So we multiply 1 with 0, so this is what I have mentioned here. Then we multiply this one, okay, this one with 2, so 1 multiplied by 2, and again this one multiplied by, right, now we multiply this one with 0.5, so which is mentioned here. So this will result into 2. 1 multiplied by 0 is 0, 1 multiplied by 2 is 2, 1 multiplied by 0.5 is 2, so that means it will result into 2.5 again. So again we will shift 1 unit this side, right? So now n is at 2, so after moving it to this, n will be at 3, n minus 1 will be at 3, right, and so on, right? So let me draw here. Okay, so by shifting the signal again 1 unit, so now you see that n is at index 3, right, n minus 1 is at 2, and n minus 2 is at index 1. So if you multiply the corresponding value, so this is 3, right, so at 3 the signal is 0, whereas the response is 1, so 1 into 0 will result into 0 as mentioned here, right? So 1 into 0. Again for the second sample, this is at 2, and again at 2 the signal is 0, so 1 into 0 will again result into 0. At position 1 the response you can see is 1, and the signal has value of 2, so 1 multiplied by 2 will result into 2. Okay, so if I move one more position to the left, to the right, you will see that the non-zero overlap is 0. We don't have any non-zero overlap. What does non-zero overlap mean? Non-zero overlap means that both the response and the signal are non-zero, so we call them non-zero overlap. Okay, so shifting it one more position to the right results n equals to 4, and when n equals to 4 you see this is the fourth position. So here the response is 1, right? Response has value of 1, but input signal is 0, so 1 into 0 will result into 0. Again at third position or third index, the response is 1, but the input signal is 0, so 1 into 0 will result into 0. Again at second position, response is 1, but the input signal is 0, so that means the product is 0 and sum of products is also 0, so we can say y of 4 will be equal to 0, and it will stay 0 for all the remaining values. So I can write the generalized expression for y of n, and I can say that y of n equals to 0 when n is less than 0, okay, and it is equal to 0.5 when n is equal to 1, it is equal to 2.5, okay, when n equals to 2, it is equal to again 2.5 for n equals to 3. Is it 3? No, it's sorry, when n is less than 1, when n is less than 0, it is 0. It is 0 when n is, next step is, okay, that I made a mistake here, so let me clear it. Okay, so when n equals to 0, y of n equals to 0.5. When n equals to 1, it is 2.5. When n equals to 2, again it is 2.5. When n equals to 3, it is equal to 2. So 2 when n equals to 3, and 0 when n is equal to or greater than 0. So this is the expression for y of n, right? So I hope this gives you idea how we can use the graphical method to find the convolution integral, convolution sum. Okay, so the resulting signal y of n is plotted here. Okay, so you can see before 0, right, it is 0, and after 3 it is 0. So we can say when n is equal to or greater than, uh, again it's wrong, when n is equal to or greater than 4. Okay, so for all values of n where it is equal to or greater than 4, this signal will, the output signal y of n will be 0. So let's consider one more example where we are given input and the impulse response, and we have to find the output of the system. So these are the two, that is response and the input signal. So input signal has value of 2 for n equals to 0, 3 for n equals to 1, minus 2 for n equals to 2, and 0 otherwise. So that means for all of the values of the n it is equal to 0. Similarly, response equals to 1 for n equals to plus minus 1, 2 for n equals to 0, and 0 otherwise. So that means for all other values of n it is equal to 0. So let's plot the two signals, right? The first step is that you plot the two signals. So for example, this is your signal, that is okay, this is n, and you plot the values. So the signal is x of n equals to 2 for n equals to 0, it is equal to 2, then it is equal to 3 for n equals to 1, so this is equal to n equals to 1, and here it is 3, and for n equals to 2 it is equals to minus 2, right? And this is x of n. So this is 0, this is 1, and this is 2, and this is your, okay, just for my convenience I write x of n here, where normally you know that we write it near the 0, like you have to write it at this point. Okay, so again I write the response signal, right? So you understand response signal equals to 1 for n equals to plus minus 1. So this is this is equal to 2 in fact, right? So at 0 it has value of 2, at 1 it has value of 1, okay, and at minus 1 again it has value of 1. So this is 1, and this one is 2, right? So let's make it a bit large. So now it looks like 2. Okay, so the first step is to replace the variable, right? So again, this is h of n. So okay, for my convenience I am writing it here. This is h of n, right? So the first step is to replace the variable by k. So you have to draw it again, right? Redraw it. I'm not redrawing it, I'm just replacing it because it's difficult for me to draw this. So I'll just say okay, and this one, and then I say okay, now I write this is k, right? So this is k, and this is k, and this again k, right? So anyone you can reflect, okay? So it's up to you whether you reflect the response or you reflect the input signal. So okay, I reflect the response, okay, because it's easy, it looks easy. It has two it's two polar or bipolar, because here you have positive amplitudes and negative, so maybe it's difficult. I don't know. You can, anyway, you can do any one. Okay, so I'm just reflecting the h of k. So you understand how to reflect. So it's something like you put mirror here, so you see its replica this side, and if you put mirror here, you see, so you see the signal is actually symmetric, right? So it's a symmetric means it's an even. So if it's even function of the independent variable, so that means its reflected version will again be the same what it has, right? So it is something, again, it's like this, and this is your h of minus k, right? So if I add a big negative value here, then because it's at position 1, this is at 0, this is at minus 1, so this will go to n plus 1, this will be n, and this will be n minus 1, and it will be for big negative value of n, it will be shifted this way, right? So let's draw it here. So I hope it gives you idea how it's working, right? So let me plot here. So this point, if I subtract a big negative from it, if I add a big negative value with it, it will result into okay, so okay, so we have, right, this point will shift this side, so this is n plus 1. Okay, so the next one will be this one, this is 2, right? This is 1, this is 2, and this is again 1. Okay, so this is n, and this is n minus 1, right? So you see this signal has only 3 non-zero samples, right? Right, so it doesn't mean it's just how many, for example, this is 0, so 1, 2, 3, so, and now it's actually so many unit shift to the left, right? So this is your k, and this is h of n minus k. Okay, so the first step is the plotting the two signals. We have already plotted, then we replace k with we replace n with k for both the signal and the response. So we have done that. Then we reflect one of the signal, that is the next step. So we have reflected the signal h of k, this is the next step, and after that we add some big negative value of n, so that we shift the signal to the left side. This is the next step, and then the next step is to multiply the corresponding values. So if you look at this one, you understand this is the signal, which is 0, right? It's 0 at -1, -2, -3, and so on. So all the values up to infinity, they are 0. So what does it mean? It means now, because the first right, now we will multiply the corresponding values. So values here, they are non-zero. Let me remove this arrow. So values here, they are non-zero, but the corresponding values here, they are 0. So what happens, it means that it will be right. So this is basically a different color. Okay, so these are zeros, right? So you get 0. Okay, so we, just like in the previous numerical, we wrote y of n equals to 0, right? Because one signal is non-zero, this signal is non-zero, but this one is 0, so the product will result into 0, and the summing the zeros will result into 0. So this continues, right? So for all values x, right, that you move, right? So you understand the next step is you shift this signal 1 unit this side, that is right side, and then again you repeat. What is a repeat? Repeat means you multiply the corresponding values, sum the results. Okay, so again you shift 1 unit this way. Again this signal is non-zero, but this one is zero, so summation, so the product will result into summation, as the product will result into zero, and the summation of the zero will result into zero. So this continues up to where? Up to n plus 1 equals to 0. So when n plus 1 equals to 0, at that point this will be non-zero, and again this is non-zero, so we have some non-zero value for y. So what is that value of n? That value of n plus 1 equals to 0. That means this will continue. N plus 1 equals to 0 means n equals to minus 1. So that means y of n equals to 0 for n is less than minus 1. So for all values where n is less than minus 1, it will be 0. Okay, so what will happen for n equals to minus 1? So y, okay, so n equals to minus 1, you understand, means that y of minus 1. So y of minus 1 means, right, so let me draw the signal. So I've shifted to this side. Now you see 0, this is 0, right? You understand, this is 0, and this is 1, this is 2, and so on. This is minus 1, this is this, right? So if you can also say that n equals to what? N equals to minus 1, because this position is minus 1 and n is here. So, or you can also say this position is 0 and you say n plus 1 equals to 0, so that means n equals to minus 1. Okay, so if you look at this one, so you see that still at this point, if you see okay, this is non-zero, and again this is non-zero, whereas this is 0, so product of this with this will result into 0. This is 0, so product of this with this will result into 0. So that means we have 1, okay, I just write 1 multiplied by 0, right, plus 2 multiplied by 0 plus 1 multiplied by 2, right? So how I get this? So this is basically you see, this is 1 and this is your original signal. This is also, this is equal to 2, so 1 into 2, whereas this here the signal is 0, this, right, whereas this signal has value of 2, so that's why I wrote 2 into 1. Again at this position this signal equals to 1 and this signal equals to 0, so I wrote here 1 into 0. I hope this gives you understanding how we are doing or how we are calculating the convolution sum. So that means it will result into 2. Okay, so again for y equals to minus not minus 2, it's already minus 1, so now we move 1 unit this, 1 unit to the right. That means y equals to y of 0. So if you shift the signal 1 unit, now this n plus 1 will correspond to 1, so you have something like this. And let me do it quickly, so that's okay. So I've shifted 1 unit this way, so again we do the same corresponding multiplication and then summation. So maybe we can use a word that is SMS to show how the convolution sum is done. So the first S means shift, right? Then we multiply, okay, and then sum. So we can say this basically follows S M S, right? Shift, M for multiply, and then S for sum. Then again shift, multiply, sum. Okay, so we shift, then we multiply. So when we multiply, this is 1 into 3 will result into 3. Then this is 2 into 2 will result into 4. Again, this one is a 1, but this is 0, so 1 into 0 will result into 0, and this will give you the answer 7. Okay, then again you for y equals to 1. Okay, so I hope you understand. You can do it by yourself. So when you shift one more unit, then you say this value, which is 1, this corresponds to -2, right? This is 2, this now will correspond to 3. I mean, the respective value for this will be 3, so 2 into 3, and again this is 1, and this will be multiplied with 2, so that means I'm not shifting it, right? I mean, I'm just shifting it in mind, so you can do it because it will take a lot of time, so I just go quickly through it. So that means I get this last one, this is 1, and this corresponds to 2 if I shift it 1 unit, so that will be 2 into 2 plus, sorry, this is 1 in fact, right? So this will be 1 into 2, then the next, this is 2, and this is multiplied with 3, so that means 2 into 3, and then we say plus, then again we have 1, but here it is -2, so 1 multiplied by -2. Okay, so I hope you get the idea. That so 2 into 1, 2, 2 3s are 6, 6 plus 2, 8, 8 minus 2 will be 6, right? So we have y of 1 equals to 6. Similarly, I just write y of 2. So y of 2 will be, you can do it by yourself. I just write the answer, which is hopefully 6 minus 1, right? Y of 2 equals to -1. Y of 3 equals to is equal to -2. You can verify it. Okay, so and and this is equal to y of y of 4. Okay, just write me here y of n, right? This is equal to again 0 for n is equal to or greater than 4. Okay, so that's the final answer. So I just write this as something like, okay, so this is your y of n. You can plot it. Okay, you should plot it so that you know how it's working, and also the rest of the step, because I didn't go for, I go up to y of 1, and I hope you can go. So just and check this and verify whether I am wrong or I am right. Right, so this is for the convolution sum using graphical method. Okay, so I want you to do all these steps and do it by yourself. Okay, so in general, the number of equation to find the number of points, number of non-zero points in the output, which is y of n. So how many points will be non-zero there? So this is the expression for it, where nx is the number of non-zero values in the input signal, and h is the non-zero values in the response, -1. So this is the equation that gives the number of non-zero values in the output y of n. So y of n starts at the sum of 2 sequences starting points non-zero, right? So that's the starting point for the y of n, and the y of n ends at the sum of the 2 input sequences ending points, right? So we're there. So you just sum the two. For example, one started So for example, in the previous problem, uh, x of n started at, right, start point of x of n was, start point was for example was 0, right, 0, and and start point of h of n was so the start point for x of n was -1, and for h of n was -1. In fact, it was 0, right? So the start point for y of n will be 0 -1, which is equal to -1. So y of n will have the non-zero value starting from -1. Similarly, the end point of x of n was 2, right? The end point for x of n was 2, and the end point for h of n was 1. So that means the end point where the y will consist of zeros, that is beyond 3. So up to 3 y of n will have non-zero values. Beyond this it will have the 0 values. Okay, so similarly, how many samples will be there? So if you look at the previous example, in the previous example, the number of samples in the input signal was 3, and the number of sample in the response were also 3. So that means 3, and again -1, so -1. So that means the non-zero samples in y of n will be 5, right? So exactly these were, right? So this is how you can check back using the example we have done, right? In fact, you can verify this for the both of examples we have done in this lecture. So I think we end the lecture, and the examples shown here, or the numerical problems shown here, will be done in the coming lecture. So that's all for now. Go through all the lectures, right, video lectures, and also the slides you have been provided on, and we will have a live session where we'll discuss about the problems you have. So don't forget to go through the videos over and over again so that you have clear understanding. Okay, see you.